This is Unit 6, Lesson 12 of our Pre-Calc 12 class. Unit 6 is called Conics, and Lesson 12 is called Hyperbolas, Round 2. So in this lesson, we are going to finish covering some more key features of hyperbolas based off its equation. So either way, whether it's opening up and down or opening left and right hyperbola, we have two asymptotes that any hyperbola follows. And here are the equations for those asymptotes based off of our HK values from the center and the A and B values for the distance from the center for vertices and covertices. We can write these two equations, and these equations are based off of our linear equation for a line given the point, a point on the line and the slope. The slope is going to be made by the ratio of b over a, or the square root of the number under the y squared over the square root of the number under the x squared. And then hk is just going to be the one point that's on both graphs, so we'll use that point for our x1 and y1. And so here's the general form for point-slope equation of a linear equation. Y minus y1 equals m, the slope, times x minus x1. x1, y1 just being any given point on the line. And if I add y1 to the other side, I get this form right here. And then, of course, since the center is our point on both lines, h is going to be x1 and k is going to be y1. So that's where that comes from. The asymptotes fit nicely into this little box right here. So if we know our A and our B, we know our vertices and covertices, whether it opens up and down or left and right, those are our pairs, whichever one is which, vertices and covertices. And so if I take those and call those the midpoints of the sides of a rectangle, then I can create this box right here. And what we're going to find is that the asymptotes for a hyperbola always intersect the corners of this imaginary box that we just made. And so if you know your vertices and covertices, you can get around finding the equation of these asymptotes just by drawing lines through the corners of those boxes. And so in this lesson, I'm going to ask you to derive this equation, but beyond that, you can really just use this imaginary box to find your asymptotes. And in the next lesson, we'll kind of look more into those asymptotes, but for now, this is how you find them. And so also we notice we're just kind of building, this kind of builds off of the idea of covertices that we talked about in the last lesson. If we know our covertices, we can find our asymptotes. So in the last lesson, why do we have covertices? In this lesson, the answer is so we can find the asymptotes. So the new question is, well, why asymptotes? Well, stick around for the next lesson, we'll find out the answer to that. Okay, so a little nerd stuff going on here. The focus, or since there's two parabolas that make up a hyperbola, there's two foci, if you will, for a hyperbola. Each parabola has its own focus. So there's two focus in general, two foci. And if we have an opening up and down hyperbola, what we're going to do is we're going to take the square root of a squared plus b squared and add it and subtract it from our k value, which is the y value of our center. So we're going to go up square root of a squared plus b squared, and we're going to go down square root of a squared plus b squared, and that's going to give us the location of the foci. Now let's talk about the square root of a squared plus b squared. So what we get here is the distance from the center to the foci. If I think of this as a triangle, let's say I take, well, okay, so I took this triangle right here. Let's start there. This triangle right here is created by taking we're just going from our covertice and our vertice, and we're just adding this fourth point with the center to make this nice little rectangle. If I draw a line from that point we just made to the center, and then from that point to the vertex, then we create this nice little right triangle with a height of b and a width of a, because it's equal length of our covertice from the center. And so Pythagoras' theorem will tell us that a squared plus b squared equals c squared. So the length of this hypotenuse of this little triangle here is the square root of a squared plus b squared. And now if I take this triangle and I pivot it, I keep the point of the triangle that is the center where it's at, and the other 2 points are going to rotate. What we're going to find is that our imaginary point we created will spin and be directly overlapping with our focus. So if you create a rectangle or a triangle that goes out B and then takes 90 degrees to the right and goes to the right A, we're going to end up at our focus. All that to say is that's kind of a intuitive approach to reasoning why we have this square root of a squared plus b squared. But all you need to know is that it is what it is, and here's what it is. So that's if we have an opening up and opening down parabola. We take that square root of a squared plus b squared and add or subtract it from the k, or the y value at the center. If we have a hyperbola that opens left and right, we're going to take that same square root of a squared plus b squared and add or subtract it from the h, or the x value of our center. And it's going to be an analogous reasoning for here. We can create that same triangle. It's going to be a to the vertex, and go b up, we get this triangle. And if we pivot this triangle on the center, we're going to find that not only is my graph not super to scale, but this point on our triangle is going to overlap with the focus. As a matter of fact, I'm just going to edit that point right now. Alright. A little better. Still not great. Alright, so that's our new stuff, our new key features for this lesson. Key features of a hyperbola. We have these two asymptotes that kind of intersect the corners of this imaginary rectangle we can make from the vertices and co-vertices. And we have foci, 2 of them, just like an ellipse. Hyperbolas and ellipses have a lot in common. Here's an example. So we have a y squared minus an x squared, so I know it opens up and down, which means I'm going to add or subtract to the k value to find the foci. Let's see here. So if our a squared is 16 and our b squared is 25, then our center is at 2, 1, then we can say 2, 1 plus or minus the square root of our a squared plus b squared, which is 16 plus 25, which is the same as the square root of 41. So one focus is at 2, 1 plus the square root of 41, and the other focus is at 2, 1 minus the square root of 41. And because the square root of 41 is not a simplifiable rational, we're just going to leave it like that. Also our asymptotes, it's plus or minus b over a times x minus h plus k. So we just plug in a, b, h, and k, and we have our asymptotes. There are 2 of them there. Because of this plus or minus, we have a positive fraction and a negative fraction. If you split that up, you can get 2 different asymptotes. Second example, we have an x squared minus a y squared, and so this is going to be opening left and right hyperbola, which means we're going to take that square root of a squared plus b squared, and we're going to add it and subtract it from the x value of the center. So h plus or minus the square root of a squared plus b squared, comma k will be the 2 foci. Since h is negative 4 and k is positive 4, then negative 4 plus or minus the square root of 36 plus 1, or a squared plus b squared, comma 4 are going to be our 2 foci. Square root of 36 plus 1 is square root of 37, which we're not going to simplify because we can't with whole numbers. So negative 4 plus the square root of 37, comma 4 is 1 focus, and negative 4 minus the square root of 37, comma 4 is the other focus. And now our asymptotes, again, it's plus or minus b over a times x minus h plus k. Since our h value is a -4, we can simplify this just being y equals plus or minus 1/6 times x plus 4 plus 4. And again, there's two asymptotes there because of the plus and minus. Alright, so that's it for this lesson. We've talked about all the key features we're going to talk about for hyperbolas. The new key features in this lesson are those two asymptotes. I think this is the first time we've talked about asymptotes that aren't strictly vertical or horizontal, so that's cool. Also, we've talked about how to find the foci of hyperbolas, which is also cool because Pythagoras gets to stick his head up again and say something. That's it for this one.